Okay, this is a good Doppler problem, and I like it because it's kind of a conundrum. So pause the video and read the setup. Okay, hopefully you've done that. So we're going to look at the same thing from two different standpoints. We have a sound source producing 1 kilohertz waves. So in part A, the source is moving toward the stationary listener. In part B, we still have the same source, but now the listener will move toward the source. And we're going to figure out what the Doppler shift was in both cases. And you would expect those to be the same. You would think that all that would matter is the relative speed between listener and source. It doesn't matter which one's moving toward the other, but it does. It matters. So this is the more advanced version. Your book doesn't even have this formula in it. This is the more advanced version of finding a new frequency due to the Doppler shift. V here is just the speed of sound in air, so 344 meters per second. VL is the speed of the listener. VS is the speed of the source. And there's this weird sign convention. Notice we got a plus minus on top and a minus plus on the bottom. So if the things are moving toward each other, we use the top symbol. If they're moving away from each other, we use the bottom symbol. So just for the completeness here, if the source and the listener are both moving, you got to be really careful with your pluses and minus. If the listener is moving toward the source, use the plus, away, use the minus. If the source is moving toward the listener, use the minus. If it's moving away, use the plus. Toward is top, away is bottom. Okay, so in part A, only the source is moving. The listener is not moving, he's 0. So VS is the source. Because the source is moving toward the listener, we're going to use the top symbol here, minus. So we just plug in all of our numbers. Here's our original, the actual real frequency. This is what the listener will hear. The guy sitting on the street with this siren coming at him hears a 2000 hertz tone. Okay, then part B, it's the other way around. Now, the source is stationary, but the listener is the one moving. So again, we're using this same formula, but now the listener is moving at half the speed of sound. We're going to use the top because they're moving toward each other. Use the top, plus, and we get 1500 hertz. So it's the same source, it's the same relative speed between them. They're still moving together at half the speed of sound. If the source is moving toward the listener hears 2000 hertz. If the listener is the one moving, he only hears 1500 hertz. Why the difference? Because the Doppler effect is caused by motion through the air. What matters is not the relative speed between the two objects. What matters is the source's speed relative to the air. That's what makes the difference.